Hello, everyone. Once again to Thinking Out Loud episode. My name is Fran Mendez, for those of you who don't know me. And I work as a director of the Async Api initiative and also director of engineering at Postman. So I like to introduce this all the thinking out loud episodes. Start by saying like what is it about, right? Like what's thinking out loud? Like is it a podcast? Is it something like a just a live stream, or what it is? Like what does it have? What is special about thinking out loud, right? And so let me explain. Like thinking out loud is it's a space, it's a live stream, right? That I host here every week so far. Let's see if we can keep this rhythm. And I invite people to join me during this time and discuss a little bit about specific topic, right? Every week is a different topic, and even though sometimes I may ask questions to the guest, this is not an interview. This is a what I like to call a thinking process. So we're here to think out loud, like for real, um, and we may end up producing some good thoughts and coming up with some good thoughts, and may not. So let's see. Let's see what happens. And as I used to say, like thinking out loud can be the most boring show. So yeah, it's not the show actually. So yeah, stick with that anyway. It's not going to be boring, I promise. If in case you like event-driven architectures, APIs, and and thinking about these things. So before I forget, in case you need or prefer to have subtitles or closed captions, we are only able to enable this on YouTube. So please head over to YouTube to watch it there, and I made sure that closed captions are enabled there. So today, what's the topic for today? So today, I wanted to invite I think it's already an old member of our community. It's not because he's old, right? It's because it's been here for a while, and yeah. So we wanted to discuss about something that happened in a thread in a Twitter thread, like it's not that something happened. It's like things that were discussed there, and some people were contrary to um, what Async API is doing, or the way Async API is built, or like in some ways like it's negative feedback, right? Like we don't usually get a lot of negative feedback, and that's sad because I'm sure we're not doing everything well. I mean, I'm sure not. I know we're not doing everything well. It's impossible. So yeah, I like to hear good feedback, positive feedback, but I also like to hear people saying, "Hey, so this is not quite good, and this probably have to be changed," right? And so yeah, so in this thread, I discovered that in this thread, Ian was involved, like given this his opinion, and yeah, I already said the guest name, right? So Ian Cooper, I'm inviting Ian Cooper today to discuss about like the current state of Async API, what can be changed, and so on and so on. So let me introduce Ian, and I'm sure he will be able to introduce himself much better. Hey, Ian.
Hey everyone.
So, oh, I'm hearing myself a lot. I don't know if you have some headphones or something, because I'm hearing myself and it's quite weird.
Let me check the audio and see where it's
Okay,
picking it up.
no problem, no problem. It's a
Oh, that's worse. Does that seem better?
or,
Oh no, that's echo.
uh,
Wow, that's awful.
no,
Let
that's
me
not
try a
good.
different mic.
Right. Right. For funny, it's great.
I'll try these.
Yeah. I'm gonna use mine as well. Oh, nice. Calm.
Is that better?
Yes. Can you speak again?
Right.
Okay. Now I
One,
can
two,
hear you.
three.
Yes,
Okay.
it worked. So, oh, I'm still listening to myself. That's weird. Um, so yeah, I was saying that. Can you please introduce yourself, like, to the community, just in case uh, someone doesn't know you?
Sure. Keeper. And oh, I'm getting echo now. I'm a principal engineer at the minute at Just Eat Takeaways. So we deliver you your takeaway food, and I deal a lot with a little bit, but I deal a lot there with how we get our microservices to talk to each other. So events, HTTP, any kind of interop that we're doing. Wow, I've got a lot of echo.
Yes, I was going to mention that maybe if you want to get rid of the headphones and we get back to the initial setup, I'll be happy to deal with the echo myself. I don't know if, well, maybe people also will uh, hear the echo. I don't know. Anyway, so yeah. So just wanted to mention something. I'm an like a how do you say that? Like I'm an avid user, not an avid user, but a recurring user of Just It. I like I like cooking. What the hell? What's happening? You don't know. Might be Safari. You told me you were in Safari. Might be because of that. It happens to me in Firefox. There's all these noises. So maybe if you move to, I cannot hear you now. Yeah, I think it's gonna be much better if we switch to Chrome. Okay, so while we wait for Ian to come back, is there any topic you want to talk about in the meantime? You have the chat, so remember you can send messages in the chat. Please entertain me. You feel like I'm in the cloud. What does the meme, is it? Ah, okay, I understand now. Sure, forget about it. No, I cannot hear you. No, can't hear you. So you're still in time. If you want me to, if you want to talk about something, people in the chat, um, I think it's the right time while Ian configures his sound.
But now.
Okay. Yes, now I hear you, and I don't hear echo. Oh, no, I can't believe. Yay! Finally,
You made it work. Okay, so
That's
the
good.
answer seems to be use Chrome by the looks of it.
Yeah, so it's not any WebKit server browser. it's Chrome in the end. So yeah, Ian was saying that I am a regular user of Just It. I'm sorry for those who like cooking. Like me, I actually like cooking, but I don't find time. With a baby, even less. And then I find myself like, this is much easier, right? And funny, what's funny, like in a few weeks ago, I was discussing with David Boyne, who's in the chat, by the way, that we should be creating a um, like a demo application using Async API and specification and tools, right? Not just Async API, like also using cloud events and and other standards out there, and see how everything fits together and experience the pain ourselves in first person, right? Um, because when you spend so much time developing tools, you frequently forget about the user. So so I told him like, hey, we should be building something like that. And my initial idea was I'm gonna build a Just Did clone, and I have it documented somewhere in my Notion. It's like
If it's any good, we might just use that instead. So
I can imagine, right?
it's certainly, I mean, for asynchronicity, there's certain parts of it that are obviously embarrassingly asynchronous, and that can really help in the sense that once you have made your order and pressed the button, it all happens without the need for a kind of user interface apart from us, say, pushing notifications to tell you that your order is on its way. The driver is nearly 10 minutes away, and the whole of that really can run through a synchronous pipeline. We can get asynchronicity around the user experience as well by, when you look at a restaurant or a menu, that's probably we've built a what we call a projection. Sometimes people call kind of reference data. We built a read-only store of events elsewhere in the system that effectively is actually populating kind of some of that data as well. And we try really to be, I mean, overall, we have a model that we say we want to use asynchronous communication between services because we see that as more reliable. If the other server you're talking to is down, it doesn't necessarily matter from your perspective as a service. So if you think about it, if you can't currently add restaurants to Just Eat, that shouldn't stop us serving you from existing restaurants. And if you think about it, we're not signing up, thousands of restaurants a second. We are serving thousands of customers a second, but we're okay with stale data. We're okay with restaurants as it was 3 hours ago. So that kind of model, it works very well for us in that kind of business. So it's a great example to try. And it's one of those domains that probably it works kind of the way you think it does. In terms of you modeling it out to try and basically for an experiment, a lot of it does work the way you think you can reason about how you think it might work. There are a few strangenesses around. So one of them is whether or not you care, whether we care whether the courier has actually delivered the food to you. And there are various schools of thought in the industry on that one. So one is, yes, we do obviously want to know that basically it's been delivered, but you have to incentivize drivers to basically press that button to basically say, yes, it's been delivered, otherwise they can't get. Another school of thought says we don't, because in the event it's not delivered, you'll phone us anyway and say, where's my food? And then we'll know that there was a failure of the delivery. So it's kind of interesting. There's different ways to look, but mostly you can reason about it. I think actually Chris Richardson's book on microservice patterns, I think it is, or microservices, I can't remember what it's called now, but he uses food delivery as an example, microservices. So it's also another good place to go and look for a model you could borrow for that.
Yeah, actually, I used to work for Stuart, which is another delivery company. It is more in the line of, like you can deliver anything, not just food, right?
Yeah, so we integrate with Stuart. Yeah.
Okay. Yeah, and I used to work for Stuart in the early days, and when they got their first round of investment, they hired us to build. They built like a prototype which was working perfectly, but it wasn't scalable. It was all synchronous and HTTP and so on, right? So, and it was a monolith. right? So it was working well for prototype, but they wanted to scale, right? So the design that we did at the time was, okay, we need to create an event-driven architecture here. Like everything needs to happen as an event. We need to have the mobile applications connecting with MQTT probably, if possible. Um, at that time, it wasn't like 100% possible. Like some phones were cutting the connection on MQTT, but you could use notification systems on for that, right? So yeah, like it was all. It was cool. It was an interesting project, because aside from what people can see, what people can see about, like ordering food and so on, like order is addressed or finished or rejected or whatever, cancelled. um, Aside from that, aside from food and so on, there was a team of how's it called, like um, can't remember the name. There's data scientist, right? So a team of data scientists, and they were trying to predict where the next order was going to happen, right? Or at least not the next one, but the next bunch of orders were going to happen, to send anticipatedly send drivers to that area, right? Of in this case of Barcelona, right? So, and it was super cool. Like they were taking into account many things, like Barca was playing or not. That's important. Is there a riot somewhere? Is there the streets? Is there some kind of street cat or something? Like you need
Yeah,
to know.
the raining is a big one. It
It's
suddenly
it's
starts
it's it's
raining for a
rainy.
split
Is it
second.
sunny? Yeah, exactly. It's a big one as well, and it was interesting to see how they could actually predict a high percentage of the next of the times, like the next where the next order was going to happen. It was like to me, it was like magic. Like how the hell are you doing? Like I know you get the data as events. They were getting the data as events, and they were able to compute these events and predict stuff.
Yeah,
So yeah.
one of the key problems in that industry that you don't get in, say, groceries, is that when you order hot food, you want it to still be hot when it arrives at your door. So there's only a certain distance you can travel in terms of time before your food gets cold. And also, you really want the food to be just fresh out of the oven when the driver arrives to pick it up. And there are a lot of attempts to use machine learning to refine those times continuously, so that we get we can shorten the time between food leaves the oven and arrives on your plate to the lowest kind of waiting time added to actual time for travel to you. And even think about things like, in the event there's a lot of traffic or it's raining, are there certain restaurants we don't want to show you anymore because we can't get you the food hot?
Yeah.
And it's kind of a problem
Yeah.
until you work in that sector. It doesn't necessarily occur to you that delivering you hot food is an additional problem beyond, say, delivering you a milk bottle, which, the milk bottle doesn't tend to go off during the time to deliver from your local convenience store, but your food could well get cold. An ice cream could melt, right?
And I find it funny, something that you said before, is that many of these things are not being triggered by a user behind the UI. So this many of these things are just a weather API reading the temperature, or if it's raining or not, and then sending an event and about changes, and then activating certain services or updating certain services. So like, well, maybe if you think about it, like there's someone updating the weather data, right, in some place. But yeah, like
but it
there's
pushes
no
it
one, there's no, yeah, like
that
there's no
reacts.
one on Just It in this case, or who works for Just It updating this information. It's just all continuously happening as you receive events, and that is huge. That is actually huge. I love it. So if I'm not mistaken, I think you were using Async API. Just it. Is that correct?
So we are, yeah. I mean, we're at the beginning of our journey, I would say, with it. so we have a lot of APIs that, in terms of event-based APIs, async APIs, and by comparison to the HTTP APIs, where we use OpenAPI, our realization was that we just didn't really have any useful way of discovering them. If you were, as the organization, if there's only like, I don't know, 10 of you in a room, right, you can just shout over the desk and say, "Oh, anyone got an API?" But we have, I don't think we actually even, I don't know the exact number, but it's an order of 1,000 odd engineers and large numbers of components. So that breaks down. You can't really even it's not even really a reasonable practice. So that's what people did, to go into a kind of public channel on Slack and literally say, anyone know who raises this event and where it comes from and what the schema is? You can't really do that either. People would try trawling GitHub searches to find stuff, right? Particularly with events, hey, I need to find who consumes my event that I'm sending out, or effectively, has anyone got an event that deals with this aspect of stuff? And you might find over time you've got 2 or 3 events that are actually doing the same thing, because we've kind of, there's just so many of them. So we needed to get it under control. And Async API seemed like a really good way for us to say, okay, we can standardize how we're going to document our endpoints. And then we may be able to use tooling, or hopefully, if we're lucky, tooling effectively arrives in the Async API space just fast enough ahead of us that we can then do much easier discovery of those APIs.
Yeah.
Potentially also do ability to understand our flow, because I talked about the other day saying, in typical event architectures, you've got these 2 approaches: choreography or orchestration. And so orchestration, I've got a component that directs everything. It's easy to understand, but it doesn't scale very well. And then you've got choreography, where I send an event to you, you send an event to them. If there's an error path, it goes this way. And the problem a little bit is it works. All the dancers have their steps they perform, but we don't really quite often have a laid out, here are all the steps in the dance. So it can be difficult to understand what's actually going to happen. So and particularly for someone in operations, something happens and they go, "Oh, I don't know what happened in that context." And being able to map that out is also something we thought, maybe if we get standardized documentation for endpoints, we're able to map stuff out, right? So, we're looking at interesting ideas like event catalog to see quite how that's being picked up. Scaffolding would also be useful to us, the ability to really, generate first versions of consumers, particularly not less senders. But the other thing we also want to use it for is generating infrastructure. So an ability for you as a developer to simply say, "Hey, I need basically to talk to expose, to publish something via SNS, or I as a consumer want to subscribe to that SNS channel via SQS." Right? And what we would like to be able to do is, rather than have teams to take responsibility for provisioning that themselves, for us to be able to essentially say, "Fine, drop that in your repo, we'll pick that up, and we will go away and provision that." And the reason that becomes important at a certain scale is, if for some reason we have an incident where we lose, for example, a given channel in, say, SNS, it's very hard for us to then figure out, well, who subscribes to that. If I know that channel's gone for some reason and I recreate it, I also have to recreate all the subscriptions. Where are they? Do I trawl GitHub to find them? And so documenting all of that process. So it's the other thing that's why I got interested quite a lot in the bindings, was because what we wanted to do with it was have enough information in the binding to then say, okay, I can go away and create that infrastructure on that given broker. I mean, we tend to use SNS and SQS and Kafka. There are some pockets of RabbitMQ and MQTT in the org as well. But that's why that became important to us, that kind of idea. We want to better use it to drive infrastructure as code effectively.
Yeah, that's cool. And actually, what I hear as well is a common let's say complaint about event-driven architecture, specifically, like choreography, which is funny. I created Async API out of a need while doing choreography, choreographied microservices. And I was feeling the same thing, like, damn it, this is this is growing super fast. Like we were doing microservices wrong, I will say. Like probably everybody.
Yeah, I think
But-
everyone goes through this first phase. I think when it becomes too fine grained, they hear the word micro and go, "Let's go really small."
yes,
Or,
we were doing a small, yeah.
yeah, or when they extract, it's kind of like, well, I could take this function call and make it a microservice. Yeah, so
Yes.
that's I think a first that everyone makes.
Yeah, we were kind of doing something like this. Like we were going micro in terms of size of the code, and yeah, that's not the point, right? So, but yeah, like we like quickly get a lot of new um, services, right? Microservices, and all of them were doing different things, but their code were looking um, mostly the same, and except that it was just subscribing using the same framework, subscribing to the same broker, and then doing something with the event or publishing to the broker or something like that. And then on the documentation side, on the discovery side, it was hard to answer this question, like who is subscribing to this event, right? Like who's gonna be receiving this event, and it's important, especially when something blows up. Basically, it's like when something fails, and it's like, who's getting affected? I don't know, and this I don't know is like, look at the broker. Yeah, it was a broker, the piece that failed, or something in the broker failed. So you can't really look at the broker, or the broker is not reachable because of a network problem or something like that. And then you can't query the broker or look at the information there. So and then it's scary, right? And it gets even more scary when it's not just your infrastructure, your private infrastructure, but you're sharing some of these events with third party, with other companies, right? With partners, right? And they're doing something with these events. And then it's like like I can query, like you said, like I can query GitHub or GitHub organization and so on, but I cannot know if it's not somewhere else in a document or something which partner is using this event, right? And so we were documenting these things by hand in a document in a Google Doc or something, like trying and praying that it didn't that Google Docs doesn't go down, right? And we can access this, right? And so yeah, what I hear all the time is discovery and governance, right? It's always the same thing, like discovery and governance. Yeah, generating code, it's cool. It's something that you might want to do. It was, for us, it was a big deal because we had like an in-house framework for subscribing and publishing to the broker. And so we were iterating on the framework as well at the same time as in the product. So whenever you released a new version of the framework, you wanted to go to all the microservices and update their code to update to the newest version of the framework, uh, which is which is a pain, right? It can be automated. Now we have more means for that, right? But back in the days, it wasn't, like CI wasn't really a thing, and it wasn't, or if it was a thing, I honestly I didn't know how to do it myself. So, and our team, so yeah, it was a pain. And so yeah, so this is like this is a really common, let's say, complaint that I hear from people, like and complain about event-driven architectures and an advantage that Async API can give you. Less so, I hear about infra as code, right? Or infra or defining infra as on the Async API specification, which is something interesting. Like it was out of scope from the very beginning. We got lots of requests for that. I mean, a few of them, not lots. And
Yeah.
but yeah, like
I mean, what traditions we work internal framework? When I actually work on I think a couple of teams use it at Just Eat, but I work on a .NET open source library that we used a lot in my previous gig called Brighter. So, and it, like Just Saying, which is the one that comes out of Just Eat, another .NET kind of library, both of those have this kind of model which says, okay, as a consumer, I'll generate the necessary infrastructure to subscribe, and as a producer, I'll generate the necessary infrastructure to publish, and they self-service, and that works up until a point. And so Brighter, which I worked on, it was kind of the first time I really built a big messaging framework that was open source, because I'd done it a lot of times and didn't want to write again another job. We started off really focusing on RabbitMQ was the first transport we really had. And RabbitMQ, those creation statements are idempotent, right? So if the queue already exists, doesn't matter. I just say I'm going to recreate it, and it's very low latency. When you start to deal with cloud infrastructure like SNS and SQS, one of the things you find is that first, it's not idempotent. So you will get an error if you try basically to recreate something that already exists. So you have to kind of test and say, does it exist? Or you have to try and catch the error and kind of abandon it. And the second is that when you're running multiple consumers, using a competing consumer pattern, when you're scaling out, if the first thing that does when it scales out says, well, I have to check my infrastructure, that's always a delay. And then if it says, I've got to create it because it doesn't seem to be there, it's missing, but you've got 4 or 5 and they all then hit a race condition, they all want to create it. Well, one of them succeed, the others fail because it already exists. But do they know that it failed because it already exists? Because they're inside an if loop saying, does it exist, right? So it gets quite complicated, particularly cloud infrastructure at scale, to let consumers create it themselves. So we said, well, actually, that's a pain point. And then we coupled that with, well, do we really want developers in the organization to have all the rights required to do that? And do we really want to create the scenario where they could fail easily at something that requires that they only have to do every so often? Or do we want them to focus on writing their kind of domain logic in the same way that their framework today takes care of that? We really want to take care of it for them outside the framework. And so we ended up saying, well, what we really want to be able to do is support the idea that your infrastructure is created outside the framework. And so it's kind of a flag or an option we give people now to say, hey, infra is created. And then we said, well, we could use Async Api if we're asking you to define an endpoint anyway, for documentation purposes, for governance, as you say. I don't want to force you to define something else, right? Because that's the classic developer problem of, I have to fill out 5 documents and I'm now really annoyed. If you just let me fill out 1 document to describe my endpoint, I'm good with that. And so for us, the binding info looks like a really useful way for us to give the information that you need to give us in order to basically configure the infrastructure so that we can take away the job of creating it as part of our deployment process to make sure the infrastructure exists in that environment. And I think particularly as you begin to move towards, areas like Kubernetes, etc., it becomes more powerful to say, hey, let's take over the work of creating the infrastructure. Let's then create environment variables or the like that give you anything that's created at runtime and inject them into your given environment. You can look for those, and anything that we need you to create, you need the address identity of, we'll pass that back to you in that environment. So we've got that kind of running, and we're really going to start trying to roll that out. And then there's a whole backfill process of trying to backfill everybody who's doing it themselves onto, can we take control of that for you? And in theory, you get closer to the ability to be able to say, let's spin up everything again in an entirely new place if we need to. But
so are you? I'm curious now how you do it. Like, are you only using existing information on the Async API document, or are you defining any specific extensions of your own for infra?
So I've got a PR in somewhere for Async API's bindings for SQS SNS. That contains a lot more detail. That's why we've got that detail in there. We do also have like a custom binding for any additional information that we think, well, that wouldn't be generic. That's something that we care about. So we'd add a custom binding to give you where you can specify some additional properties that we might need. And then we use the generator to turn that into to pull out the information we need from the Async API specification to really just be effectively a dictionary of the values that we need to set. And then under the hood, we're using Pulumi to then actually go away and create the infrastructure from the properties that you give us.
Nice. Sounds like a good talk, right? I would love to watch a talk on how you do that.
Yeah,
or a blog post.
Until we've had this conversation, I've not realized that maybe we are, pushing the envelope in a different direction for people. So maybe we should talk about that. Maybe I encourage one of the devs on the team who's doing a lot more of the implementation. And I did a kind of first proof of concept, and they've really taken it to the end. So if I can persuade one of them to do more of a talk about it.
Oh yeah, that would be like super cool. So and speaking a little bit about coming back to the original thread where this invitation happened and so on. So I'm curious. I'm curious, like where. How can I say it? Like I know more or less now how you're using Async API and so on. But what are the pain points for you, like on the Async API side? What do you think it doesn't really fit well when you use Async API?
Yeah, the thread, I think, really, actually, I think the strongest part of the criticism came a little bit from Clemens Vastas, who was looking at Async API, and it was more by trying to understand his criticism. I mean, I think we have some of the classic pain points that everybody has around, publish and subscribe, around the channel name not necessarily being the actual being a logical concept we want not the actual identifier for that item, because we may have it in multiple environments, etc. And you need to pick up the name which has been in that environment, etc., etc. So we have a lot of those classic pain points. But digging into what Clement said, I think I began to understand what he was driving at. So one thing I think is more of I don't know, there's a misunderstanding on his part. In terms of, say, how RPC might be seen, you might be defining on a server a set of operations, which effectively are behaviors that the server exposes, if you like, as an API. And then a client asks for those specific behaviors. And I think Clemens' perspective is that from a messaging point of view, that's rarely true. Now, I don't necessarily entirely agree with him. I think that from a point of view of command-driven messages, you are quite often driving behavior. You are saying, hey, go and do this specific thing for me. So you can do that messaging that way. He might argue that's still a kind of RPC, just an RPC over messaging. When you get into the world of events, you're not really trying to drive a specific operation. You're communicating some facts inside an event, and really all you're doing on the far side is saying, I'm listening to events, right? And somebody else on the other far side says, I'm publishing events, and in between, things can happen. And I think that he's over time in those conversations, I think people have driven a couple of things. The first is that when we think about an asynchronous conversation, what's the characteristic? This is what Async API is. What's the characteristics of an asynchronous conversation? And really, the key one is that both parties don't need to be present. Right? And how do we make that work? Well, the analogy I might use is I put what I want in a letter, and I go to your house and I put it in your mailbox. You can be out. I go away. You come home, pick up my letter, and you read it. Right. So we don't have to both be present, and that's kind of a metaphor that we use a lot, right? I am delivering you some kind of post. And I think what's in that letter is a little bit this behavior thing, right? In order for it to be more RPC-like, it's almost as though I've sent you something where I've asked for a specific thing that you offer and you give me that, right? So I say, oh, can you send me one of those cute teddy bears for my daughter or whatever? I'm just going to top my head. And you go, yeah, great. So that's kind of an instruction of some behavior you said you've exposed. I'm using messaging to get a hold of it. But the way I get a hold of it is more I send you a message, and in the message, the content would tell you that. I'm not really sending it to an endpoint called, buy teddy bear or whatever. I'm sending it to your house, where effectively I know that you run your business and you look at the message and interpret that to figure out what you do. So it's a slight shift in the sense that saying operations seem a bit strange in that world, because I'm not really asking you for an operation. You are saying I'm willing to receive messages, and I'm saying I'm sending messages. And then you get into this world a little bit of brokers, which I think is a really interesting kind of topic. What is a broker, etc. So if you think about it, if I send you, if I come to your mailbox and deliver it, I'm just doing that to myself. I could do it by the post office. I could go to a mailbox, put it in a mailbox, post office then delivers it to you, and then kind of receive it. From a messaging point of view, arguably, the main difference is what are we talking to? Am I talking directly to your mailbox or another mailbox, or something invisibly happens in between? But it's still really pretty much a point-to-point interaction, right? I'm sending it to your address. I put your address on the front, and I say, this is for you. Slightly different to that is when we get into pub sub, because what I tend to do there is I'm not sending it to a specific address. I'm kind of sending it to what we tend to call a recipient list. So on the front of my thing, rather than writing, 24 Acacia Avenue, I might write everyone interested in my newsletter. And then what happens is it goes to somewhere where effectively they hold this list of who's interested in subscribing to my newsletter, and they send everybody a copy. And when we think about brokers, it's interesting to understand, what do we mean by a broker? Do we mean someone at the post office, where really it's still a kind of point-to-point interaction? I'm delivering it to a specific person, right? And I put their address in it. Or do we actually mean something more like a router, right? Where effectively the router's got some rules of how to deliver stuff to people, and a recipient list is a typical router. So one of the other interesting questions is, what do we mean by channel, right? So a channel, if you look at kind of the Gregor Hope kind of theory of it, it's just basically how two things kind of communicate. It's a virtual pipe. And in principle, what we often think of as my distributing messages via a broker is really me with a channel. It might be to TCP IP. It may not really have any store and forward characteristics, talking to a broker where there's essentially a recipient list, which is what we call a dynamic recipient list you can sign up to. So a topic or a routing key, which then distributed to a whole set of channels, which are probably queue-based. In other words, they have store and forward characteristics, which consumers then subscribe to. And I guess one of the questions is, when we think in terms of channels and servers, etc., are we missing concepts or ideas there, in the sense that when I say I'm an app that I send something, well, what am I sending? I'm sending a message, and I'm sending it to somewhere, right? And I could be sending it to another party that listens to it, or it could be sending it to a server, but I'm probably sending it to a channel. But the question to do that, so I send it to a channel, but where does that channel go? So the channel might go then to a broker, right? Which then says, okay, when things come on here, I can effectively, your message would get routed to this topic, which would then transmit it to everybody by another channel. So the question really, when we think about the relationship between channels and brokers, is, are channels really on-ramps and off-ramps onto a broker? And the broker really, from our point of view, mostly does things like, one example is act as a recipient list, where effectively, but it forms some kind of router. So you might have some channels and a router in this model rather than channels and a broker. And you say, well, I've got this channel which talks to the router, and it's TCP IP. This channel which I read off the router, which is basically AMQP's protocol for basically reading stuff off the a queue, right? And both three AMQP, but basically one's not doing any kind of store and forward, one's got a queue. So I've got a queue on, and I've got basically TCP/IP on. And here, what I'm doing is routing, and what I'm saying, the kind of routing I want to do here is everybody in a recipient list, so people can subscribe and then effectively to this topic, and then they'll get a copy of it. But there could be other types of routing I might do, right? I might have a set of rules based on the content of the message. So I could say, what I do is, if it basically turns out when I inspect the content of the message that effectively large orders over $1 million go here, and orders between medium-sized orders down to 100,000 go here, other orders less than 100,000 go here, that router is no longer really doing that kind of classic pub sub model. It's using a rules engine to determine where things go. And I guess the question would be, in Async API, do we, if we think about a server and we think about channels as belonging to a server, do we miss that kind of aspect of really the broker as something a little bit more than that? It's acting as a router. It's probably got a rules base. It's probably thinking about different rules for how you then distribute work out to channels. And would point to point really be much more, we share a channel, right? And the server might be, sure, it might be a server that hosts the channel, right? But then we actually physically have that channel on. But a broker might be a thing on a server in the same way, so you've got a server, you've got channels that may be hosted on the server. You might have a router or something, or you might call it more on the server that says, well, how does this channel get to that channel? Right? There's this kind of separation between point to point. We're sharing, we're using the channel just to communicate over, or hey, I send to something to basically an intermediary, a router that effectively then distributes for me to other channels. And that's an interesting kind of question as to whether we do we want to understand more of that kind of topology in Async API.
I actually, it is very interesting because we need to draw the line somewhere, right? Like where do we stop? Like we define until here, otherwise it can get really complex, right? And I think that's why. I know that's why I stopped there. Like, okay, I'm not gonna get into rules on how routing happens in the router and the broker and so on, right? Because then it's like we're entering another land, right? And that's why I called it Async API, right? Like API in the sense of it's just an interface, it's just a surface, right? Like I don't care what's happening behind the scenes. Like that's why I never explored infrastructure as code, because it's like I don't care what's your infra behind it. Like I'm telling you, right? Like I'm communicating to people. Like how can they communicate with me? Like how if you want to send a message to me, you gotta send a message to this broker on this channel, and then I'll receive it, right? Or you can subscribe from my messages on this broker and on this topic, right, on this channel. So or it can be like this last channel, which is like there's only one channel, there are no channels, it's just a TCP connection, for instance, and that's it, right? So there are no concept of channels. So when you have that concept, like so it is highly frustrating trying to think in these terms, because people often get confused about publish and subscribe meaning, and it's because you see publish and you see subscribe and you think this is the behavior of your application, like your service, your microservice or whatever is going to publish and it's going to subscribe to this topic on this broker, right? But it's not. So this is not the meaning of the publish and subscribe. It's actually like if someone wants me to receive this email, this event, you gotta send me the message on this channel, on this broker, right? So effectively, it is more complicated to understand, but effectively what it's doing is like it's like abstracting the whole infrastructure. What is like I treat the whole infrastructure as a black box. Like I don't care what's happening in there, right? I'm just telling you like this application. If you want to communicate with this application, this is what you have to do. Instead of this application is doing something. It's not what the application is doing, is what you can do with the application, right? Like how you can communicate with the application. And I think if we stick to that model, then there can be any routing rules in the middle that you don't really care, because it's like if you want to communicate this one, or let's say not communicate, but if you have a publisher here and you have a subscriber here on a specific type of message, not necessarily on the same topic on the same channel, what can happen is that I publish on topic or channel A here. There are some routing rules in the middle, and it gets published to channel D, right? And this one is subscribing to channel D and receiving the message on channel D. So here is described that I'm subscribing, or you can publish to me, let's say I'm subscribing, right? On channel D. And here I'm describing that you can subscribe to the messages that I'm publishing on channel A, right? So the cool thing is that you don't have this problem, like everything can be abstracted in the middle. The worst thing here is that it's highly complicated to think in that terms. Like look at what I just said. Like you can publish to me, right? You don't publish to anyone. Like this one is subscribing to the topic, to the specific topic in the broker. You're not publishing to the microservice, right? So I'm in like in more strict terms, might be that the broker is publishing to the microservice. If it's using a push model or something, then okay, could be happening. But yeah, like from the application development point of view, it is highly confusing to think in the terms. Now, for version 3, we are reverting the meanings of publish and subscribe. And to make it clear that we're reverting them, we're even changing the names. So it's going to be so far, the way it is so far, it can be still changing. There's still time. It's send or receive. And these times are operations, let's say. These are actions, behaviors, not what a potential client or another person can do with the service. It's what the service is doing. Like send means the service is sending the message to the broker. Receives means that it's receiving this message from the broker, right? So trying to make it a little bit clearer and less confusing.
Yeah. So I think one of the areas of confusion a bit is if you. So I think the first point from that conversation was to try and move away from the idea that you perceive the operations as being an API surface area, right? Mm-hmm. What you're really saying is, what do I do to this channel? I can't think off the top of my head of a better word, action or something, or but what you're really saying is, am I sending or receiving, right? What am I doing to this channel? I'm either want to send for the channel or receive for this channel. It's almost the app says, really wants to say, hey, I've got some send actions, and I do them on, and I push this to this, this message to this channel, or I receive a message from this channel, right? So that's a little bit, and like we say, we're thinking out loud. So I don't really necessarily have a better way of describing that, but I think that's one of the criticisms is we don't want to think about having a set of behaviors you can engage with. We are literally just saying there is kind of a pipe, and I am effectively on one end of the pipe, and I'm either pushing things in or I'm receiving things. And then, and so as an app, and I may do both. I may have some things I'm listening on and some things I'm publishing to. And then in the middle, I guess, yeah, I agree. There's a level of complexity you don't want, but you could think, well, actually, I could have the notion that some servers are just basically servers where effectively I'm hosting a kind of point-to-point channel. Some servers are servers where essentially I do routine, right? And whether effectively you have a kind of a specialization of that object to say, oh, well, actually, it's acting as a router. So what it's going to do, you know that effectively, if you send something to that channel, effectively, it's going to route it to everything else that basically shares that name, or whatever, right? So it's an interesting question of if we treat channel really as, because it's doing double duty. So I think that's what the problem is. It's doing double duty as both for point-to-point scenario, it's the thing you're kind of communicating over, and for pub sub, it's kind of like the routing key. If you just treated it as this kind of identifier on the server that we use to essentially connect two things together, the channel, that's really what you thought of channel as, then really you could say that the behavior of that channel depends a little bit on the type of the server object that you put it into, right? And I know we've got this kind of idea at the minute of local and remote, but you potentially wonder whether is a kind of pub sub server a thing, right? Where effectively we say, okay, right, I know that if effectively I've got I listen to a channel on a pub sub server, that probably means that somebody's published to a pub sub server and everybody's connected to it and getting it, right? Or if it's basically a point-to-point kind of server, that means that we've got a narrow communication between the two of us, and it's me listening on one at the other end. Now, is that useful? I don't know. That's an interesting question. The question is, does that level of depth of understanding that, does that provide utility to anybody, or is it just basically noise, where effectively we don't care, it's really just a box. We just need to know that basically this thing from here goes to this thing here, and we need to understand how it works. But it's just an interesting one, that there's a level of abstraction missing, if you like.
That's actually if it provides any level of utility to people, that is actually a good concern, right? Like when I started drafting this proposal for version 3 to solve the problem with publish subscribe, I was listening to lots of different point of views, and actually that's how Thinking Out Loud started. Like I started this live streams as a way to gather feedback from the community, right? Like what is wrong in your opinion, right? Like what can be doing better, and so on, right? And what I understood by listening to the community is that there are people who are mostly interested in generating code, for instance, generating code and reading and generating documentation, so the user or potential customers, they have everything they need to communicate with their infrastructure. So treating effectively as an API in the end, even though the protocol might be AMQP or MQTT or whatever. But yeah, like you send a message and you don't expect any response, but you know that something will happen on the other side, right? And it's like, you know that if you publish here, something will happen, even though you don't get a response. So yeah, effectively is an API use case, if you want. That's one. That's precisely what we have right now on version 2, right? But so thanks to Dale at IBM, I also discovered that some people are not really interested at all in the operations. Like, I just want to list, like, where's the broker? Here are the list of channels, and here are the messages that you should be publishing or reading, depends on what you do, if you publish or subscribe to this channel, right? So it's like effectively like a menu, and there are no operations. It's just a list of things. Like, so here's channel A and message A, channel B, message B, right? And or a set of messages or whatever, and that's it. And then they don't care about who's publishing or subscribing, right? So it's not interesting for them, because they most probably, I mean, in their case, it was because they are working on a kind of API gateway, if you want, like an API gateway, but for events. So they don't really need to know who's publishing or subscribing. It's just, I want to I want to look at the event that is being published to this channel and see if it's correct or not, if it matches the definition on the file, and if it doesn't, I'll reject it and do whatever, and if it matches, I'll let it pass, right? So that is a use case, right? And what's the other one? Yeah. Oh yeah, and the other one is that people, like people wanting to define the whole architecture they have, or at least domains, right, in a single file, right? So yeah. So what's your opinion about that, by the way? Like having a single file for, I don't know, for domains or for the whole architecture. Like
We tend to really want, I think, a file for an app with basically what that app sends and receives. Although the idea of being able to reference a menu, I think we tended to call it at the minute, document that basically has a collection of messages, etc., is helpful, because obviously if I've got an app that's 12 apps that receive a message that this one over here is sending, I really much want to better refer to that message document rather than having to inline it everywhere. And so what I'd like is these some essentially defined things like message contracts, and then app defined things like what channels do I talk to and what messages come over those channels. But most of that would be references to things that were are a central pool where I can actually pick stuff out of. So I want to know this app does this in a separate file, but it can pull stuff from that pool of globally defined resources.
That's cool.
So on just before we get there, so the other thing I think on this point, the last thing was, I think people like Clemens and people that we're getting into, right, is one of the things that's also out there a little bit where there's not necessarily a good solution, right, is when we get into the world of things like Kafka Connect and KSQL. So in something like Kafka Connect with KSQL, what I might do is say, hey, here are 3 or 4 streams, right? Pull them in and then run it through, say, KSQL, aggregate some stuff and produce out another stream at the other end. Right? So in other words, I take in information in this form, right? And I actually aggregate it in some way and put it out the other. I think one of the points is, how would we represent that? Would you represent that by having an app that effectively listens to those and then produces new messages, right? Or would you actually want to have another kind of primitive? So it's this idea of basically having particular server types that said, okay, well, when you have this server type, what we can show is that these channels map to this channel. So I guess what I'm wondering at is, if you increase the number of server types and you have some slightly different characteristics on each server type, beyond saying local and remote, but to actually be slightly more explicit and say it's this kind of server, does that solve some problems for you? That some people can say, hey, the kind of server I'm interested in is making this look like an API with a range of behaviors that I basically expose. Oh, no, I'm interested more in a pub/sub style server where effectively it's going to have this model. Actually, I've got an event stream server where effectively I may want to combine streams together and aggregate stuff. And that's the only question I have, is if local remote is perhaps not far enough down that line. What we need are other abstractions, potentially an expandable list in the future, right? So people could say, well, we don't represent this, and you could say, great, we could create a new server type with some properties on it, which would enable you to represent how that works and make that kind of more extensible thing. If we're saying, hey, my server hosts channels, and what I do then effectively is talk to a given channel, you could still represent things like, oh, in this type of server, you can represent, it would have properties that let you represent these incoming channels mapped to aggregate to these outgoing channels, right? And then over here in this app, I just subscribe to that outgoing channel. And particularly in this model, if I've got an app defined in a file, but I've ended up with some kind of things that are global resources in kind of a menu, particularly my broker, it may be that having different types of that kind of intermediary, if you like, being able to represent different types of intermediary lets you represent some of those topologies that in the future we might find people want to document, other than just the use cases we have right now, which are more classic RPC style and pub/sub style. So I mean, most of the arguments today are about RPC and pub/sub, so you can make them explicit types. But I think we may find there are other types out that people want over time.
Yeah, right now it's implicit, like the the meaning of channel in regards to servers or brokers. It's implicit to be, in the case of brokers, it's implicit to be PubSub, right? Like,
Yeah.
and in the case of point to point, it's usually RPC, right? So it's a single
Yeah.
channel or no channel, depends on how you want to call it, right?
And we're
So,
using
yeah.
local and remote for that, I think, currently. And I don't know that's necessarily that
No,
obvious.
not necessarily. I mean, I don't think it represents the same. So the thing is that local remote is from the perspective of an application, of a service that you're defining. Is it a local server that I'm exposing, like an HTTP or WebSocket server, or is it a remote server like a broker, right?
Okay.
Like what you're defining, right? Then inside the server definition, you could be saying type, I don't know, aggregator, type PubSub,
Okay.
type whatever.
Yeah.
So it's still compatible. The local or remote is more about the perspective from the service being defined on this file, right? On the
All right.
specific
Am
file.
I the server effectively? Yeah. So I guess you might be RPC and server, RPC or local. Actually, remote or local. But in other words, do you
Yeah.
expose the APIs?
Exactly. If I am the server,
Yeah.
yeah. If I am the server, I will be defining it as local. If you are a client, then you will be defining it as a remote, right? Or pointing it as a remote
Yeah.
server, right? Because you're not exposing this interface, right? It's somewhat
Yeah.
it's me, not you, right? So yeah, and that's why now in the new version, what we're aiming for is you need two async API files. In the case of client server, you need two, right? Not like before, like we were saying, like you can just define the server, for instance, and then the client can be like how can I say it? Like the client can be not generated, but like the client, you have enough information to generate a client if you want,
Yeah.
right? But it's not true. Like it's not really true. Like we proved to be we've been proven wrong, right? Like and then it's and that's why of client server we should treat it the same way as in a broker based topology, right? Where there's a broker in the middle, and then you have service A and service B, which is the client and the server, and they're communicating. There's no broker. That's the only difference. There's no broker, but you still need two async API files, right? So that's why. And I think this thing about aggregators like KSQL and things like this, the fear that I have about going that deep, like defining these routing rules on an async API file, is that from what I've seen in my experience, none of these rules are static. You know what I mean? So
Yeah, but I think it's less about defining the rules in the Async API document, which I think is probably, I think it might be a step too far because you really get into quite very implementation specific stuff. But I think it's more about being able to follow the path, right? So I think what most people want, if you think about that kind of documentation discovery aspect, is being able to understand where does this channel come from, and so one of the concerns people tend to have in environments with lots of, say, KSQL stuff floating around is, so and so basically over here is subscribing to this topic basically and reading information, right? But we don't clearly know that as the sender of another topic that there's a relationship between the two, because essentially he's subscribing to an entirely different topic. And I may say, oh, well, I've got, subscribers to my topic, but actually they've all been retired, so I'm going to turn myself off, right? And then this guy at this end basically, whereas I'm suddenly getting no more information. How did that happen, right? And that's because there's no way of tying out that his topic came from that. So I think there's quite specific things that people want, which is more the discovery aspect rather than the, let's encode all the rules here. It's more, this black box needs to, if we think about the black box where things go in and things come out, I think it's a question of being able to make sure that there's a very simple case where, A goes in, A comes out, right? And that kind of works a bit for PubSub or even for RPC, because we're both, the kind of more RPC point-to-point one is just saying, well, A always maps to A, right? And there's one consumer on each side, sort of thing. And the PubSub says, well, A maps to many consumers of A. But what we really want to be able to see is, in some cases, it might be A maps to B and C through some black box thing that's happening. And that's, I think, the interesting question is whether that's representable in some way, so that you would know that, oh, okay, A is actually has got some dependencies here. It gets transformed here to B and C. That's what I want to understand. It's that connection I want to know, not the not what is the transformation that's done, not the rules of transformation, but the transformation has happened.
You want to know like potential, let's say, potential channels where this message can end up being routed to, right? Like, so it might get routed to here, 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 and you don't want to define the rules. It's just like saying, hey, so this channel might be routed to these other 3 channels. The logic, we don't care. I'm just telling you that there's some logic behind, and it might get routed to this.
So now I can see the dependencies. Now I can understand there's a flow somewhere. The logic of the flow. Any more than I don't know the logic if your app basically receives a message and raises a new one. I just know that it does, right? And even that is true a little bit. I don't necessarily. I think this is one of the points that got raised in a part of that thread was, if my app receives a message, right? Receives a message foo, doesn't work, and then raises a message bar, there isn't a clear way for me to be able to trace that foo has with what leads to bar, right, coming out. And if I want to trace how something then moves through the whole application, I think that's the key point that was kind of, particularly Clements was driving through on that thread. How do I see how things connect across the wire? And I don't necessarily
that's going to be
how to do that, and it may be V4 rather than V3.
Yeah.
But I think there's an interesting challenge there for us, of which things like that case equal example are just a specific case, right?
That's going to be interesting challenge. Also, in how to visualize that, because like there will be, you can see, I can imagine a diagram like like David was doing with event catalog. So you have a diagram where you can see like this service is publishing this event here, but it might get routed to any of these 3, right? Or multiple of these 3, right?
Or there's a transformation
unknown, or there's transformation, and then this becomes another message. And like even just the connections, like visualizing, like, so there's a link between this and this, but it's not this like a strong link, right? It's a weak link, like in the sense of sometimes it might be it will be linked, and sometimes it will not, like because there's a rule
generically at some point you just want to show algorithm runs here. So routing is really what you're suggesting is something does routing, right? And one of the puzzling things is to begin to think, when we think about a router, we tend to think about, in messaging terms, this almost third-party piece of software that basically has a set of ways that it routes something. Or the RabbitMQ comes with basically its exchanges, which are really just routers, right? But really our app, right? If our app consumes a message and spits out a new one, effectively it's acting as a router. We don't think about it that way, but effectively it is. And so it's one way of saying is, how do we express that concept so we can do that process of tracking stuff, or can we do it in a way that's reasonable?
I can see where you're going. So I think we're over over the hour already. I didn't want to interrupt because we started late, so no problem.
All sorts of strange don't use Safari issues, but I don't have any answers yet, just questions. So there's no point in, maybe we should leave it open now to the audience to say what the answer to our question.
Exactly. So I try to make these episodes always as collaborative as possible. So this one, we either got people bored and they left, or or they are listening to us very closely, and they didn't want to interfere, and so we didn't get any questions. But if you have any questions, I think it's the right time to ask, I would say. And if not, you know that we're always on Slack and then Twitter and many other platforms, right? So yeah, you don't have to ask now, or I mean, ask or suggest anything. Like you can interrupt at any time. Not today because we're gonna finish, but but in the next ones, right? So yeah. In the meantime, Ian, thanks a lot for joining. It's been really a pleasure. And yeah, if you have anything else to add, like something that you want to say, to message to send to the Async API community, or feel free, or if not, that's also fine. Yeah, so.
Yeah, no, I mean, I think the main thing I would say is that I think Async API, it is a tremendous step ahead from where we are, and I see a lot of smart, motivated people who are working to make things better with every iteration, and I've got real confidence around the community that we're going to get from step to step, and with each iteration, really solve a whole new slew of use cases. So, and I definitely don't want anyone to think that I'm negative about Async API. We definitely pretty much, we're bought into Async API, and it's more about what other challenges can we see that we need help with. That it might be interesting to understand if Async API would be the tool to help solve those as well. I think it's more what I'm suggesting. But no, I'm completely. I wouldn't want anyone to get the impression that I am critical in that sense of the efforts. We're definitely very much behind it. It's more, hey, where could we go next, sort of thing.
Yeah. Well, I agree, and we all need to learn to be to listen to different types of feedback. That's why I after this conversation on Twitter, I wanted to invite you, like, hey, let's discuss this in public, because I think not just in public but over a call, right? So because Twitter is not really the right place to discuss these things. It's too short, and and chaotic. Also, the organization of the information is really chaotic, and not really a good place. But happy to always listen to all types of feedback. I think it's really useful. This conversation has been really useful, and I hope it's, at least for me, and I hope it's been for for the rest of the people, those who have been watching, those who will watch the conversation later, and yeah, like, I encourage you, Ian, and everyone else watching to give also, to also express your frustrations or what you don't like. Or of course we all like to hear good feedback and how good you are and blah 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 and so on. We all like to be loved, right? But if you want to grow, if we want to grow well, and make something really solid, right, as a community, we can't be silencing the the bad feedback, or the negative feedback, not the bad feedback, the negative feedback, right? Or the frustrations from different users. So yeah. So thanks a lot, Ian. Really appreciate.
My pleasure. And can I just say on that last point that your openness does you credit. I mean, I think that's one of the things that I think is great about this community, is the willingness to be open to other viewpoints, to take on board what people are saying, and I think hopefully people do feel that sense that you want to engage, because I certainly feel that.
Yeah. Thanks a lot, man. So see you on around on Slack and so on, and on GitHub, and yeah, let's keep chatting. Please don't leave. We'll have a chat after the live stream. I'll just take you out. Cool, folks. So thanks a lot for watching today. It's been over an hour, but I hope you found this content interesting. As you know, you can find us on Slack, asyncapi.com/Slack-invite. If not, just go to Slack, to the asyncapi.com website, and in the menu you can find a Slack invitation. And yeah, just join us. We're trying to make it like really community driven. I know that these words are very often used by different projects, like it's community driven, blah 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 blah, bullshit, right? No, we're trying to make it really community driven, and as you can see, we'll listen to all types of feedback, and yeah, so leave all your feedback whenever you think whenever you think about it, right? So see you again next week. I'll be announcing soon who's the next guest, and cheers. Bye bye. Take care. By the way, we have a really cool outro right now coming now, which is done by Missy, who's in the chat, Missy Turco, and yeah, and I forgot. Like he's gonna kill me. Damn it. Let me just anyway. I'll say it another day. No worries. Cheers. Thanks a lot. Bye bye.